Hi Srivalli.
Hi, Shanti.
So, what is the demo you are giving today?
So the demo is about evaluating machine learning lifecycle in terms of cost analysis and comparing it with Gen AI implementation.
So, it means basically the people who are all using machine learning activities, they can convert easily into generative AI after your justification. Looks like, is it right?
Yeah, yeah. Actually, some of the ML models that have been implemented as generative AI services by Azure, they
Hmm.
are very impressive in terms of cost and resource usage. Um,
Hmm.
but not all of the ML models are implemented. So, but at least we have the advantage of some of the ML models being implemented. And translation service is one of such models. We are going to analyze based on translation service today.
Okay, please go ahead. Yeah.
Hi, I'm Srivalli. I have about 16 years experience in IT industry that includes various roles. My latest experience being at Microsoft Redmond. Today, I'm going to demo the evaluation of machine learning life cycle in terms of cost and resource. I'm going to compare. Uh, I'm going to present a comparison between the machine learning model development and the Gen AI implementation. Um, and we are going to take a look at the translation service as an example. Um, and this is as part of my job coaching on Azure Cloud DevOps and generative AI services. Let's begin. So first, to start with, agenda. We're going to have a brief overview of machine learning, just a small introduction about what machine learning is, and then ML lifecycle activities. We are going to visit the ML lifecycle activities, importance of cost analysis when considering ML model building for implementing a business use case. Um, Assessing the costs and resources involved in different machine learning activities, data pre-processing. We're going to discuss as part of the ML lifecycle activities. We are going to discuss data pre-processing, model training, sentiment analysis, feature engineering, evaluation and validation. And then after we have discussed these steps, these are the major steps while coming up with an ML model or while implementing ML lifecycle. After we have visited these steps, we are going to compare um, the ML model building with implementation using Gen AI services. And then cost and resource, we're going to discuss the cost and resource comparison. Okay, let's quickly go through what ML is. Machine learning enables systems to learn from data and make predictions or decisions without explicit programming. It involves a range of processes, including data gathering, pre-processing, model training, and evaluation. Um, and then just to go through the ML lifecycle activities, some of the major activities, because we are going to discuss the cost analysis here. So some of the major steps or some of the major activities here are data pre-processing, model training, sentiment analysis, feature engineering, evaluation, and validation. Here's a brief overview. This flowchart depicts the uh, ML lifecycle activities, um, define the project objectives, and then we collect the data that is required for that project. And then the raw data is not ready for model building. So we have to first do cleaning and pre-processing of the data. And there are going to be Azure tools that have to be used for data cleaning and pre-processing. And then so this is a iterative process. So we time and again check if the data is cleaned and pre-processed to our satisfaction. And if it is, then we go ahead with the feature engineering step. If it is not, then we go back and we further apply um, our rules to do the cleaning and pre-processing. And then feature engineering, model selection. Um, so if the feature engineering is successful, then we are ready to select the model. Um, if we are ready to select the model, we go ahead, select the model, and do the model training. And if we are not ready, then we go back to the data cleaning and pre-processing step. And then model training. And then from model training, we go to, is model performance satisfactory? Now, while measuring the performance of a model, there's the sentiment analysis, one of the activities that is involved in model performance, in gauging the model performance. We have to make sure the sentiments are um, rightly converted when we are translating. For example, we are doing a language translation of a text. So the sentiments have to be translated correctly. So that's one of the measures to gauge the performance of the model. And then if the model is, the performance of the model is satisfactory, then we go ahead, perform model testing. And from model testing, we go to model deployment and the model monitoring and maintenance. Um, model deployment is what makes makes the model ready for the usage. Um, Importance of cost analysis. Okay, so why do we need the cost analysis? Before we implement any project, we have to come up with most optimized solution of implementation. If there are better tools that cost less, then sure, why not go ahead, use those tools. And not every project or not every business use case needs model customization or model development, which is where Azure generative AI services help. Cost analysis is vital for forecasting expenses associated with ML projects. Understanding costs aids in making informed decisions about which ML activities to pursue based on available budget. Assessing the costs and resources involved in different machine learning activities. So let's, to get a good idea of how much cost is involved, if we have to come up with a new model or customize a new ML model, um, we have to go through the costs and resources involved. So to assess costs and resources involved in different machine learning activities such as data pre-processing, model training, sentiment analysis, feature engineering, evaluation, and validation, and to compare these with Gen AI implementation using translation service, we need to consider factors like compute resources, storage, services used, and the data volume. So looking at the data pre-processing step, the Azure resources involved, just to give you an overview of, doesn't necessarily mean you have to use these resources, but just to give an idea. So these are the resources used. We can use log files and media files for input, and business or custom applications could also be ingesting data as your data. So this is these are the steps involved in cleaning and pre-processing of data. We ingest the data into Azure Data Factory, and then um, mm, uh, eh, and then from there the data flows into data lake. So at this point, we could send this data for analytics to make sure uh, to see the quality of the data. And then we go ahead, we proceed with Azure Databricks, and from Azure Databricks, so we could populate this using from Azure Databricks, we could populate this to view the uh, data analytics or the data related any graphs or pie charts kind of thing with the data on Power BI. We could use Azure Cosmos DB if there is huge amount of data that is pre-processed and it has to be used. And then from the Cosmos DB, it can be fed into a web application here. So the web application, I'm thinking, is the one that will call into the ML model. The ML model will use this data. And then Azure analysis services. So this is related to the Azure, the data analytics. Data pre-processing. Let's discuss the costs involved. Compute resources involved are the virtual machines, data bricks for data cleaning and preparation, and the cost depends on the size of the data set, the complexity of the operations, and the time required for execution. Storage costs as your blob storage or as your data lake for storing raw and processed data. As your resources, as your data bricks, as your data lake, and as your storage. Cost factors are data volume and storage, VM compute time, CPU or GPU usage per hour. So let's consider an example here. Pre-processing of 1 terabyte of customer purchase data for personalized marketing can range from a few hundred to several $1,000s, depending on the compute resources used. And the typical cost is between $10,000 to $50,000 for a medium-sized project. And the model training is the next activity. This is the core of the ML. And what steps are involved in model training? Algorithm selection, hyperparameter tuning, and training iterations. You can see there's compute resources involved here, and there's also service. There's also an Azure service resource involved in this activity. Model training, resource, and cost estimate. So looking at the cost estimate, first, what compute resources are involved? Azure machine learning for model training using GPUs or high performance VMs. The cost can escalate with larger data sets, complex models, and long training times. So the more usage of the GPU or the high performance VMs, the more expensive it is going to be. So the longer time it takes to train the model, the more expensive it is going to be. And also if the data set is larger, it's going to take longer. And a complex model also might take time. So that's why these are the factors affecting the cost. Storage, storing model checkpoints and logs in Azure Blob storage. So this is for version control. You could use the blob storage for version control and storing the logs. Azure ML compute instances, Azure blob storage. These are the Azure resources involved in this activity. Cost factors, compute resource type, or CPU, GPU, or TPUs. Training duration is based on hours or days, and then data volume. So cost factors are mainly dependent on these three. And to consider an example here, training a large NLP model using 8 GPUs over several days could cost thousands of dollars depending on the region and resource configuration. Yeah, obviously, as your different regions, the resource costing is different. So depending on if it is expensive or if it is high costing region, you will have that will directly impact the number of GPU that will directly impact the cost. So also the number of GPUs used will directly impact the cost. Typical cost for this activity can be estimated between $20,000 to $500,000 depending on the model complexity. And the next activity in this is the sentiment analysis. So if you remember, we discussed this in the beginning of the presentation in the flowchart. Sentiment analysis is part of model gauging activity. So costs involved here are mainly based on the API costs and the compute resources. API costs are the mostly text analytics API. So this is the API that will help do the sentiment analysis, and then charges per transaction. So Azure Cognitive Services charges per transaction. Example, 1,000 documents analyzed. Compute resources, if custom models are used, additional compute resources for fine-tuning or training. So you do the sentiment analysis and you find that it doesn't quite translate all the sentiments. So you have to do the fine-tuning and model retraining. So keep retraining the model is what fine-tuning is. And as your resources, as your cognitive services, as your machine learning, these are the Azure resources. And text analytics service is the Azure cognitive service involved here. Cost factors, number of text samples or documents processed, number of API calls. Um, And then example, to consider an example, sentiment analysis on 1,000 documents using Azure Text Analytics API might cost a few dollars, while custom model training could escalate the cost based on compute resource usage. Typical costs might be between 15,000 to 100,000 for custom model development. And the feature engineering activity, what will influence the costs? Compute resources being Azure Databricks or Azure ML for creating new features from raw data. Storage, storing the engineered features or transformed data sets. Azure resources involved here are Azure Databricks, Azure Data Lake, and Azure ML. Cost factors are data volume and complexity of feature generation and compute time. Consider an example, feature engineering from transactional data to derive customer. Behavior patterns for 1 million records could cost a few $100s. So typical costs are included in data pre-processing and model training costs. Evaluation and valuation activity. Evaluation and validation activity. Compute resources used here are Azure ML for testing different model versions and running evaluation metrics. So this is why we have to do the versioning of the ML model at different checkpoints, so that we can test it and evaluate it to see if the model is behaving as per our expectation. And then storage, storing model evaluation results and validation logs. And Azure resources are Azure ML and Azure Storage. Cost factors, number of models evaluated, computational resources for testing. Computational resources, as we already discussed, are the CPUs and the GPUs that are used. Example, validating and evaluating a model in 1 million data points could incur costs ranging from a few $100s, depending on the evaluation metrics and compute resources. Typical costs are 10 to 20% of the total project cost. Comparison with Gen AI using translation service. So we are going to take an example of the translation service here, Azure Gen AI translation service. So Gen AI implementations using the Azure translation service for translation have a different cost structure, primarily based on API usage rather than compute or storage resources. So here's the breakdown, and the next slide is going to show the breakdown. So before we go there, so Azure Gen AI services, the cognitive services are charged. Some of these services are charged based on the number of API calls, and some of these services are charged based on the the source and the target data. In case of translator service, it's charged based on the source and the target data and number of words that are there in the source and the number of words that are there in the target. So just to give you a quick overview of the translation service, text input, and then as your translation service, you just use the text input and translation output, or you could further input it into other Azure Cognitive Services and then store. From there, it can be stored into, for example, you could send it to a text analytics service, and then the output can be stored into a storage, maybe a blob storage. Or it can be used in Azure, further used in Azure functions for some application, for running an application. And then from here, it can be input into a web application or mobile application. Translation service. All right, so the costs involved, to analyze the costs involved in translation service. API costs, Azure Cognitive Service charges based on the number of characters translated. Sorry, I previously said number of words. It's actually number of characters. And then Azure Resources, Azure Cognitive Services translator. That's the only resource that we require here. Cost factors, number of characters translated. For example, $10 million, sorry, $10 per million characters. That's way cheaper than implementing an ML model. Example, translating 1 million characters might cost around $10, which is highly cost efficient compared to ML activities that require substantial compute and storage resources. Comparison, the cost of using translation service is generally lower than building and training custom models due to the absence of GPU compute costs and resource scaling. GPUs are very expensive. And however, for high volume or complex multilingual implementations, translation costs can increase with the API usage. So we have to make an informed decision or an educated decision here. Although most of the times the Azure Cognitive Service translation service works well, but here there is again a catch. Translation costs can increase if the API usage is too much. If you have a high volume of data or high volume complex multilingual implementations, then the API usage might increase, which could directly affect the expenses. And then okay, cost and resource comparison between Azure ML and the translation service. But data pre-processing, as we already discussed, this is a small table that quickly gives you the information for data pre-processing, model training, sentiment analysis, feature engineering, evaluation, and validation. So each of these steps has its own cost, which adds up to a huge amount. Whereas when it comes to translation service, most of these steps are unrelated. Translation service costs are unrelated, no pre-processing needed. Translation, excuse me. Translation API is cheaper as it's pre-trained, and translation API costs per character cheaper for simple text. So obviously model retraining or the fine tuning is also expensive. Not directly comparable. Translation focuses on text translation. So feature engineering is not relevant here as well. And no need for evaluation in translation API because it's already evaluated. So as your Gen AI services are based on ML models that are already evaluated. So we don't need to explicitly evaluate. So none of these costs are relevant when the implementation is using Azure Gen AI. And the quick revisit of the key takeaways, ML activities involving compute-intensive tasks like ML model training or feature engineering can be costly. So these are model training, as I said, that's the core of the ML lifecycle, and the feature engineering. These two in particular are very expensive, especially when using GPUs and handling large data sets. Translation services are API driven, meaning costs are based on usage, number of characters, which is generally lower than custom ML activities. Gen AI services like translation are more cost effective for basic NLP tasks compared to training, deploying custom ML models, which require more resources for data preprocessing, training, and evaluation. And to get a good idea of the current numbers for Azure Cognitive Services or Azure the translator service in particular, I have given the link. This is the Azure link that actually has the pricing details. In summary, if you're focusing on personalized content in multiple languages using translation services, the costs will primarily be driven by API usage. However, if you're building and training custom models for personalized marketing, the compute and storage requirements will significantly influence the overall costs. So the custom models here, um, the cost of the custom models will increase if you're building and training custom models. Whereas if it is translation service, it will increase if you are having multi-language translation and complex multi-language translations. All right. Thank you. That's the end of the presentation.